Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Out of the studio today, visiting businesses in town to apply what our kids are learning in the classrooms to what we still call the real world. It all feels very real to me no matter where we are, but how does the work that you do at your school apply to how professionals handle the work in their places of business? So today we're at Bakersfield Machine Company, joined today by Patrick Goodwin, Industrial Machinist. Patrick, great to meet you, sir.
Nice to meet you.
Tell us a little bit about the work that you do with Bakersfield Machine Company.
We do a variety of stuff. We refabricate pump parts. Like as far as what I do is I repair shafts, I repair sleeves. I can make pretty much anything you need out of shafts or sleeves or you name it, we can make it.
So predominantly working in machines that support the oil industry, correct?
No. We don't work on anything really for the oil fields. We work on stuff for the pumping industry. Places like Searless Valley Minerals or U.S. Borax. We do a lot of internal pump work, rotating pumps, cylindrical pumps, those kind of things. We rebuild a lot of pumps that make the world go around, basically.
And there's that misconception in town that the two are one and the same.
Yeah, the two are not the same. Oil field is a little different than industrial as far as where it comes to like the type of work that we do. We work on big pump stuff, mostly all pumps.
So your job deals with predominantly taking equipment that may have been seen in the past as kind of the end of its lifetime and bringing new quality and new use to it. So
reconditioning it, refurbishing it.
So tell us a little bit about the process of like finding the parts that you're going to bring back to life and how you get from the beginning to the end product.
Well, a lot of it starts in our mechanic shop up the hill. We'll have our mechanics, they'll tear a pump apart and they'll say, oh, well, the shafts, bearings and seal fits are wore out and the sleeves are bad on it. Let's give it all to Patrick and let's see what he can do with it.
So you've walked us through a few of the parts that we'll explore today in our work here at Bakersfield Machine Company. We've got three main rooms. We have saw, we got spray, and I think the third one was grind, right?
Yes.
Okay, so I mean that basically walks us through the entire process from beginning to end. If we have a new part, if we have an example of a part that is getting brought in that we're going to bring back to life, how does that rebirth start in the saw room?
Well, in the saw room, if you have a part that you need to make a new part, if you say, okay, well this part's too wore out to fix it, we start in the saw room saying, okay, we're going to find out what that material, the old part is made of, and we're going to go find it in the saw room and get the right material to match it. And we're going to cut it on our saw, and we're going to start machining it and start working on it.
Now, you know, I think a lot of our viewers have a certain vision in mind with how they think of a saw, but I mean, you have a lot of different types and varieties that you have in place for a lot of different types of parts.
Yes, we have a variety of metals that we use, and we can cut anything to any size up to a certain diameter. 18 inches, I think, is the biggest diameter on this saw that we can cut. But we start with any type of material that is applicable to what we're going to be repairing or making new.
So what would be the application of this device? Just on the start, we've got our wheel conveyor here, and then this is the one you said was larger, right?
Yeah, you basically have your rollers here, and it's a hydraulic saw where you can just you lift it up with the hydraulics, you set the length that you want with a tape measure. For you kids out there, tape measures are important on a saw. You're going to get it here and you're going to measure with the tape measure how long your part needs to be. And that gives you a rough estimate. And then you take it from here into the machinist world, to where you go into the buildings and you start making it to the tolerances that it needs to be.
And it's interesting you mentioned the tape measures and how significant they are. You've got them clipped on right here at quick access.
Absolutely.
You know, a lot of students really think about rulers and tape measures as just kind of a general tool for, like, let's say, problem solving without really getting their hands on a lot of them. How significant is it to actually put the tool in your hands and measure it with your own eyes to get that precision?
Well, as far as with a tape measure, that's just going to give you a rough estimate. You're going to get a rough estimate off a tape measure. Once you've cut it at a certain rough estimate, you're going to take it from the saw and you're going to take it into the machine shop and you're going to really start getting the precise measurements.
So that's interesting. So the saw room here is designed just to get you down to the
started.
base of
Get you
what
started.
you can
Just
work
to get
with.
you started, yes.
And then when we move over to the next space, that's when you're going to get into the thousandths of an inch,
That's
to that
correct.
level of detail.
That's correct. And just to give you an idea, a human hair, an average human hair is 3/1000ths of an inch. For you kids out there, that's 0.003 in decimals. We deal with things that can get down to 0.0015 thousandths of an inch, hundredths of an inch. So things can get very, very technical in the machinist world as far as the mathematics go.
Well, we're going to get very, very technical with that when we visit our next room in our next segments. We're going to head over to the spray room and figure out how exactly we leverage fractions and decimals in precision for the parts that we are bringing back to new use. Back here at Bakersfield Machine Company, joined today by Patrick Goodwin, industrial machinist. We're in the spray room and we are talking a little bit about the process of bringing new life to older parts. So, Patrick, we're here to look at how you would start from a piece that you were able to kind of get down to a broader sense of what you'd like it to be, and walk us through how we get to something like this to ultimately where we'd like it to end up.
Okay, well this obviously was cut on our saw with the first segment when we had, but what you're going to do is you're going to take this sleeve now with the print that you would have for it, and you're going to set it up in the engine lathe over here like I have over here.
So give us a little bit of the specifications on this piece here. You mentioned this was about 12 pounds of stainless
About
steel.
12 pounds, half-inch wall, piece of stainless steel. Really similar to the one that I have in the machine now.
Okay.
The one that I have in the machine now is very similar to this. And what you're going to do is you're going to start by machining this to certain tolerances according to what your print gives you.
So let's take a look at some of the blueprints. There are going to be some parts of this that may or may not be familiar to some of our viewers, but specifically to the students that are starting to learn about decimals and circles, even with diameter, what could they read from this visual?
Well, what they could read here is they could say, okay, well, you start off with, you have your finish length, which is 7 inches. And that's a pretty easy thing. You cut it on the saw a little bit longer, maybe 8 inches, and then you're going to come in and part it off to size. But the decimals here that are real important are the inside, what they call inside diameter, that finishes on this sleeve. And if you can see how you have only 1/1000th of an inch with your decimals here. This is calling for 3.4345 to 3.4355. Well, you only have 1/1000th of an inch tolerance on that bore right there, and that's a pretty tight tolerance considered a human hair's 3/1000th.
When we talk about tolerance, we're basically talking about margin of error. How
Yes.
far off from these measurements the final product can be to still be considered accessible and functional for what you need it
Acceptable
for.
for the print, yes. It has to. These prints have to be able to pass inspection, and you have to be able to hit the tolerances on those. And the way that you do that are with the different tooling and stuff that we have here in the machine shop to measure these as you go through this process and make a sleeve.
So this is what this piece is
This
going to
is
look like
what
from
this-
across, and then this is the top view up here.
This print right here is this sleeve right here.
Oh, okay.
Everybody, this is a sleeve that I've been working on here. Everything is finished except the OD on this gets micro finished. But the inside prints and everything on the inside is done exactly to the way that print is.
So what tools are you able to get to that precise tolerance?
Very good question.
Yeah.
The tools that I have over here, you have a variety of tools. You have your micrometers. You have mostly outside micrometers, inside micrometers, and veneers, which we call veneers here will get you the overall lengths, the micrometers, inside and outside, will get you the measurements of your inside and outside.
So you're going to use a different tool based on whether you need to measure the outside diameter
Or the
of a sleeve,
inside,
or
correct.
the inside for that piece there.
Correct.
Interesting. So what's helpful with these tools, and I don't know if a lot of students would have experience or exposure to these, because I think generally they think of measurements as, okay, I'm going to get a ruler, I'm going to get a tape measure.
Correct.
These are designed to give you more precise measurements beyond simply what's marked on each of these.
Exactly. These will give you precise measurements. This sleeve here is the one we have in the engine lathe right here, right now. And what I mean by precise measurements is you're going to have to go in here and measure the outside, where if you look at the print's calling for 4.250 to 4.248 on the outside diameter.
Right.
And we use this micrometer to measure the outside.
And that's able to measure up to the 1,000th.
The 1/10 of a 1,000th of an
Oh my
inch.
goodness.
And let me show you what that means, what we mean by a 1/10 of a 1,000th of an inch. On a micrometer, everything is done in 25 thousandths of an inch. This is a 3-inch micrometer. If I go all the way down to the very bottom, and I line up my lines, this is 3 inches exactly.
Now, if you're going to need to get something smaller than 3 inches, you're going to need a different tool.
Exactly. I have another tool which is 2 to 3. Micrometers come in all different sizes. You can get them from very small to 0 to 1, all the way up to 40 inch, very high.
And each one is designed to get precision within a certain range.
Exactly.
So this would be 3 to
Now
4
with
inches.
this micrometer, it also reads in 1/10 of a 1,000th of an inch, which is your 4th decimal spot. If you kids
Right.
understand that, your 4th decimal spot. These little lines right here on the micrometer read in 1/10. All these here. For each revolution is 25 thousandths of an inch. So if this measures at 3 inches, let's say I want to go to 3 1/4 inches. I want to go all the way up to 3.250. So I'm going to line up my lines to 3.250. Now that actually measures exactly 3.250.
That's remarkable. So we're
And that's
able
how
to
we
get
use
within
like micrometers like this in the machine shop world. Now we have to use these micrometers, which are called an internal micrometer, to check with these micrometers. So we'll get a measurement. If I wanted to come in here and get an actual measurement of this as I'm working on it, I will come in and I will get a measurement of it as I'm boring it out and working on it. And then I will bring it over here and I will measure it with this, and I'll measure it.
So that's phenomenal. So that inner micrometer is used in pairing in conjunction with the outer
With the
one.
outside to get your precise measurements. Now, this is just a small part of the machine world. We also have the veneers that we work with too. And the veneers, like I have over here, these big veneers, if I'm looking to get the actual overall length, these are a big set of veneers that go up to 24 inches.
That's phenomenal.
Well, let's say on my print's telling me that it finishes, if you kids look here, 13.125, okay? Well, I just got done parting this off, but I have to go a little bit, I have a little bit more left to take off. So if I want to measure it, I'm going to get in here and measure it. I'm going to measure it. And if you look at this, if you do the inches, here's 1 inch, 2 inch, 3 inch, 4 inch, all the way up to 13 inches. 13, there's my first line at 100. I have 135. It should finish at 125. So I have 10 more thousandths to come off that face until I'm right to the length to finish it.
It's the tools that help you get the job done.
Yes.
So when we come back, we're going to step on over to the grind room and wrap up this process here at Bakersfield Machine Company. Back here at Bakersfield Machine Company with Patrick Goodwin, Industrial Machinist, wrapping up our pathway, our journey to giving new life to old parts. So we started off in the saw room, we made our way through the spray and took a look at how precision measurements can be taken with micrometers. And that brings us to the grind shop where we actually are able to get that final finish to it. Now,
Correct.
you mentioned to us that, we really live in the realm of the thousandths of an inch, the 10,000ths of an inch. And so
Correct.
when we get to this machine here, this part of the process, we have to constantly check to make sure that we're on that pathway using
Exactly.
the most precise of measurement tools.
Correct. What we have here is we have what they call a grinding gauge. And for a lot of you kids out there, it starts with your basic ruler here. This will actually rotate up and down, and you have your different sizes that you have, but it starts with a measurement here for a ruler. Let's say on this last piece, I was almost at 4, actually reads 4.25 of an inch, 4.250, which is 1/4 of an inch. That was my starting point. Once I started to set my job up and I had it in this grinder, I had to set my dials here once I laid this part on the sleeve itself. And I had to take my micrometer, which is my measuring tool, and I measured where I was at on the size. And then once I did that, I came over here and I set my dials here to where my dials worked exactly where I set them.
So you're able to set that using the left hand there? You've got a gauge? Or
Yes, I
okay.
have. What I have is this piece right here is the actual jewel, the diamond jewel that's in there that actually will take that, and I can set it right here to adjust. And you have 2 different circles here. And for you kids to kind of understand it, if I was to come right up here at the top at 0 here, and I'm at the 1 there, that would tell me I would have 10 thousandths. So let's say I mic'd my part, and I had 10 thousandths to come off of it. This is how I would set it. I would set up the small 0 at the 1, and the big 0 at the 0, the needle at the 0, and that would tell me about right there, that's 10 thousandths to come off. So for each one of these little lines that are in here, you're dealing with 1/10 of a thousandth of an inch. So I'm going to move that needle real slow. And that's how you're dealing, if I was to be removing and grinding metal off until these zeros line up to hit the size I want to be at. So right there would be size.
So for some of our students that might be starting to explore scientific notation or exponential value with base 10, like we think of 1,000 as 10 to the 3rd or 10,000 as 10 to the 4th. We're
Correct.
talking 10 to the -4th.
Yes.
It's going well below that realm of what's visible just with the naked eye. You've got to be able to use the tools to constantly check back and forth and calibrate to make sure you're at the right accuracy.
Correct.
So once we have that, we're able to put our sleeve here onto this part, and then we start grinding up with this wheel.
Yes, what we do here is we put our sleeve in here, and we've taken this chuck and we tighten these jaws down with this wrench. And then what we have here is we have an indicator. And before we do any of this grinding with this, we have to indicate that part in right here. And this thing goes back and forth, but you have to set your part in here, and you have to indicate it to where it's really round, where this dial indicator, where nothing is moving on the dial indicator. Now we're set up to do the grind work with this. Now we go to this and we say, okay, we're going to take that metal off to get it right to the size we need to be. This right here is called a chuck, and this is called a center. This moves along with this, and they keep it nice and true and square.
And they rotate at the same rate?
Yes, they rotate at the same RPMs. I have a dial on here that I can adjust my speeds. And this thing will move real slow, and this is my diamond grinding wheel, and it will come in here and it'll grind. As I grind, I can keep miking it with the micrometer to get me the size I need to adjust to here to get it right to the precision of an inch.
It's a game of thousandths, and Patrick, I appreciate you having us by and to share our gratitude with having you in and bringing Do the Math to your company today. We want to thank you with our traditional Do the Math tile
thank you.
on behalf of the program.
Awesome, thank you.
Thank
you very much.
Lots of really refined work down to the thousandths here at the Bakersfield Machine Shop.